Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories.
The Man Who Built a Sun, Edward Teller and the Birth of the Hydrogen Bomb. Imagine this: someone actually sat down and calculated something, not stocks, not the weather, nope. Something far crazier: how to blow up the entire planet. And here's the kicker: it wasn't a joke, not a movie script. It was real. A meeting room, world-class scientists, serious discussion. They even did the math. Would the air catch fire? Would the atmosphere turn into a blazing inferno? Would Earth just disappear? Sounds insane, right? But the guy asking these questions wasn't crazy. He was one of the sharpest minds of the 20th century. A key player in building the atomic bomb, and even that wasn't enough for him. While others worried about how to blow up a city, he was thinking, can I, maybe, bring the sun to Earth too? Yes, you heard that right. He didn't just want a bigger bomb. He wanted a man-made star, and his name? Edward Teller. When he was born, nobody imagined this kid would grow up pondering how to make the sun explode on Earth. 1908. Budapest. A perfectly normal-looking family. Dad, a lawyer. Logical, precise, always in argument mode. Mom, a lover of music and literature. The house smelled faintly of piano keys and poetry. One side rational, the other emotional. You'd expect that mix to produce a calm, well-rounded child, but no. Young Teller showed one thing early: he cared less about people, more about rules, patterns, laws of nature. Other kids were learning piano. He was asking, why does sound travel? Other kids kicked soccer balls. He wondered, can I write the ball's trajectory as an equation? In short, other kids lived in the world. He tried to unravel it. His father worried. A kid staring at numbers and formulas all day could go one of two ways: genius or painfully unrelatable. Mom was optimistic. She called him a bit special. Turns out she underestimated just how special. At school, he wasn't the show-off genius or the obsessed homework kid. He was quietly dangerous. Give him a problem, he solved it fast. Then he'd think, could there be another way? A few minutes later, what if the rules were different? Teachers usually reacted in one of two ways: relief or headache. Meanwhile, the world outside wasn't stable. Early 20th century Europe. Glamorous on the surface, trembling underneath: ethnic tensions, political clashes, ideologies colliding like water about to boil. And Teller? He was born into that pot. He was Jewish. At first, it didn't matter, but over time, the air thickened, pressure built up. Invisible, but real. Growing up in that environment, people usually learn two things: observe, calculate. Teller did both, differently. Others calculated their future lives. He calculated energy, particles, invisible laws. His father wanted a stable path: lawyer, predictable income, clear logic, reasonable. But when your head is full of cosmic laws, contracts don't excite you. Asked what he wanted to do, he didn't say make money or be famous. He asked, how does the world really work? Sounds pure, right? But the next question looms when you understand it: can you change it? Some people stop at understanding, others keep going. Teller? Definitely the latter. Then came the accident. It cost him his right foot, but maybe gave him a brain that refused to stop. 1928. Munich. Young Teller, studying in Germany. Life was simple. Classes, thoughts, occasional what if no one's thought of this moments. Then came the day. A tram. A split-second misjudgment, everything changed. His right foot was gone. For most, life splits into before and after an accident. For Teller, the split was a bit different. He didn't quit, didn't slow down much as soon. He was back in class, crutches, prosthetic, listening, calculating, thinking like nothing happened, except everything had changed. Physical limits forced more reliance on his mind, which was already formidable. Now, it became his primary outlet. People later said he became more focused, stubborn, hard to convince. Before, pondering problems; after, chasing them relentlessly. No rest. Most quit when life pushes back. Teller? He pushed harder. Compensation? Perhaps. Losing a foot. But doubling down on the brain, his thinking hardened. Steel-like. In science, This can be an advantage. Breakthroughs require persistence, but it comes at a cost. Hard to stop, hard to turn back. He rarely spoke of the accident like it was trivial, but trust me, it left a mark. People who lose something often see one thing clearly: time is limited. And Teller? He didn't waste a second hesitating. After that, his trajectory sped up, learning faster, researching deeper, thinking bigger. Molecules, atoms, energy itself. Understanding wasn't enough. He wanted to push the rules to the limit. Sounds like pure science, but add limits, and things get tricky. Some limits are safe, some not. Teller rarely cared. Point one question mattered: theoretically possible. Consequences? Later. Maybe someone else's problem. If he'd stayed in Europe, he might have been a regular professor. History had other plans. 1933. A name changed everything. Hitler, Nazis rise. Atmosphere shifts. Slowly, then suddenly, policies, restrictions, fear. Teller realized, this isn't temporary. A trend once seen can't be ignored. He was Jewish. In Europe, that word meant danger, not theory. Survival. Many waited, observed, hesitated. Teller? He calculated. And the result was clear: stay equals rising risk, leave equals survive. He went to Copenhagen. There was a man, Niels Bohr, a leading figure in physics. Bohr's style: discussion, philosophy, questions without immediate answers. Teller? More the type you debate. I've already calculated it. Opposites, but effective. He absorbed deeper quantum theory, not just answers, but process. Uncertainty. Europe got worse. 1935. He moved to the U.S. Packed formulas, mental models, and indecipherable notes. Life looked stable, safe, but history moves fast. In the U.S., he met George Gamow, also a wild-thinking physicist. They studied beta decay. Sound boring? Don't be fooled. It revealed the essence of weak interactions. Their work, the Gamow-Teller transition, particles changing, energy transferring, foundations laid quietly. Teller never stopped there. He wanted to see how high you could build on that foundation. Years in the U.S., steady life, smooth research, everything pointing to normal scientist. But history doesn't follow personal plans. 1939. Nuclear fission discovered, not just a finding. A signal: energy locked in atoms. Huge potential. Others saw opportunity or danger. Teller? He saw possibility. A world of how things work shifted to a more direct question: if I really act, what happens next? This is Edward Teller. A mind that calculates the unthinkable. A man chasing the ultimate limits. A man who turned thought into fire, and fire into a star. The world had completely changed. A war was spreading as science was racing. A secret project kicked off. Location: United States. Name: Ordinary Manhattan Project. Sounds like a real estate scheme, right? In reality, it was the most dangerous experiment humanity had ever attempted. And Teller, he got pulled in not by chance. He had been standing at the doorway long before anyone noticed. He arrived at a place called Los Alamos. A wasteland. No city, no nightlife, just the smartest people on Earth, and one mission: build the atomic bomb. In charge? A name you've probably heard before: Oppenheimer. Complex personality. Brilliant, sensitive, a little poetic. He gathered these scientists like a conductor leading an orchestra. And Teller? He was the one who refused to follow the score. At first, everything seemed normal. Tasks were clear: some handled theory, some handled experiments, some handled engineering. The goal: can we make it work? But soon, things got weird. Teller's attention wandered. Others discussed fission. He was thinking fusion. Others calculated critical mass. He was thinking energy limits. Put simply, while everyone else was building the first bomb, he was designing the next one. And skipping steps. When others asked, will this even work? Teller asked, if it works, can we make it 100 times bigger? Not an exaggeration. He actually calculated it. The atomic bomb splits atoms to release energy, but there's another way: fusion. Like the sun, the energy released? Massive. Way beyond a city buster. Problem? Nobody knew how to do it. At least, not yet. Teller didn't care that it couldn't be done today. He cared about what could happen in theory. So here's the image: a conference room. Everyone's focused. How do we stabilize the fission reaction? And in the corner, Teller is writing another set of equations. While the team is making matches, he's building a star. A colleague joked later, the team's goal is to blow up a city. Teller's goal? Goes solar. Oppenheimer was slightly exasperated. A team needs focus. One person keeps drifting and drifting in a far more dangerous direction. Oppenheimer tried to steer him first, finish the atomic bomb. Teller's response, sure, but let's also consider the hydrogen bomb. Also consider. Small words, huge implications. The H-bomb wasn't just an upgrade. It was another class of weapon. Atomic bombs can destroy cities, hydrogen bombs can redraw maps. At the time, it sounded crazy. Most said, focus on the immediate. Don't think too far ahead. But Teller rarely stopped at the immediate. He was a rolling equation. Once you start the derivation, it goes to the extreme. Conflict appeared, not arguments. Rhythm differences. Team, convergent, Teller, divergent, team, needs certainty, Teller, explores limits. At first, small. Over time, obvious. 1945. Testing approached, pressure, enormous, every detail mattered. And Teller, he still hadn't let go of his bigger plan. You could call it distracted. Or you could call it visionary. The atomic bomb worked till the world shook, the war shifted to history, wrote a new line. And Teller's reaction? Different. Others saw the finish line. He saw the starting line, because in his mind, it wasn't enough. Not nearly. He was already thinking, if this is step 1, how far can step 2 go? Yes, they really calculated it, not a movie. Real life, time 1942-1943. Place, still Los Alamos, the bomb wasn't built yet, everything was theory. But questions had to be answered ahead of time. What if this thing actually explodes? At first, normal questions: blast radius, shockwave strength, radiation spread? Then someone asked a weird one: if temperatures get high enough, could it ignite the air? Not a spark, the entire atmosphere. Air is mostly nitrogen and oxygen. Under extreme conditions, they could react. Nuclear temperatures approach the sun's core. Could the reaction be unstoppable? Could we set the sky on fire? No laughter. Everyone knew this wasn't a joke. So the calculations began. Top physicists together, arguing the unthinkable. Would this burn the Earth? Thermodynamics, nuclear reactions, energy transfer, every variable considered. Air density, temperature thresholds, reaction probabilities. Logical, yet absurd. The room was tense, terrified. It was like discussing, should we press a button that could destroy the world? Then someone said, hold on. Let me check the math again. Possibly the most dangerous double check in human history. Teller participated, of course. He loved pushing questions to the extreme. The boundary this time? Could the Earth survive? The answer? Yes. The reaction couldn't sustain itself. No chain burning of the atmosphere. Earth survived. A collective sigh. Then they carried on. This is the weirdest part. They had just verified one wrong step, and the world might be gone, and they said, good. Let's keep building. Not madness, extreme rationality. If probability equals 0, then it's safe. As for one wrong step, ignored. Teller thrived in that logic. For him, the question was never should we. Only, can we? If yes, then step forward. He didn't betray one person. He betrayed an unspoken rulebook. After 1945, the war ended, mushroom clouds faded, but Los Alamos didn't calm down. Simple goal: survive first, moral questions later. Now, a new, harsh question emerged: had they gone too far? Oppenheimer reflected, as slow, heavy, we have seen hell. Teller? Not done. He didn't see the end. Others hit brakes. He hit the gas. Others said, enough. He said, not nearly. Soon, disagreement became a rift, the rift became a divide. Early 1950s. Hydrogen bomb debate, Oppenheimer opposed, this is not a weapon. It's destruction upgraded. Teller supported, if it can be done, it must be done. Philosophy? No. Position, science doesn't just calculate. It takes sides. 1954. Security hearings, Oppenheimer at the center. No courtroom smoke colder than a courtroom. Questions, loyalty, not formulas. Can you be trusted? Silence. Then Teller spoke, cautiously. Restrained a meaning clear. I'd rather entrust national security to someone else. One sentence. Heavy, not simple opposition. It was, I don't stand with you. Imagine the room. A team member, the closest to you, says I don't trust him. Science community socially evaporates. Oppenheimer lost clearance, kicked out of inner circle. Teller kept moving forward, pushed the hydrogen bomb, stood on the stronger side, never returned to the old circle. Some called him a realist, some a dangerous idealist, some bluntly the guy who turns science into power. Not a simple right or wrong point. Two worldviews collided. Stop and think versus don't stop. When you have the power to change the world, who do you listen to? The atomic bomb? That's a matchstick. The hydrogen bomb? That's a sun. Early 1950s. Tension in the air. Thick. Growing thicker. The Cold War is heating up. The US and the Soviet Union? Two cats staring each other down. Blink first, you lose. Edward Teller? He wasn't blinking. He was thinking, why not just crank the lights to full? So he teamed up with Stanislaw Ulam. One dreamed big. The other calculated hard. Together, they cooked up a design that sounds neat and academic but is actually downright crazy. Teller Ulam configuration. The name? Calm, clinical. The reality? Insane. Atomic bombs split atoms. That's fission. Hydrogen bombs? They ignite with a fission bomb. Yes, a bomb. To light a bomb, then the energy from that blast compresses and heats another pile of material, and then fusion happens. The sun does the same thing. Light atoms smashed together, fusing, releasing unimaginable energy. A hydrogen bomb isn't just a bigger bomb. It's a man-made mini-sun. Sounds sci-fi, right? But the real question, how strong is it? 1945. Hiroshima. About 15 kilotons of TNT. 1946. First thermonuclear test, IV mic yield? 10 megatons. The difference? Hundreds of times over. And so the upgrade path became clear. Bomb. Bigger bomb. Even bigger bomb. Then someone finally asked, have we gone too far? Too late. 1954. Castle Bravo test. Expected, a few megatons, actual, double. Maybe more. Of scientists? Stunned. Not wow, amazing. More like, wait, something's wrong here. Radioactive fallout drifted, hit fishing boats, reached civilians. Think they had full control? Not a chance. Sometimes, the bomb chases its own math. This is the essence of the hydrogen bomb, not a precise tool. An energy monster. You can design it, but taming it? Nearly impossible. Teller knew this. Still, he pushed on because in his world, the question wasn't is it dangerous? It was, what if they have it and we don't? That one question outweighs any equation. So the hydrogen bomb was born, and humanity entered a new era. Not, can we destroy the world? But, how many times can we? The logic was absurd, but true. Science isn't a straight path. Sometimes, it's like a video game, unlocking new skills, then realizing, this skill is way too powerful. And just when you think Teller was just the guy who makes bigger explosions, the story twists. If there hadn't been a war, his life could have looked very different. Back in quieter days, Teller wasn't thinking about bombs. He was thinking about the universe. Like the work with George Gamow, Teller transitions. It sounds academic. It's about why some seemingly impossible changes happen in atomic nuclei, like someone jumping a wall they shouldn't be able to with their work. Figuring out the rules of that cheat code. This research, no city destruction, no shockwaves, but it shaped how we understand matter itself. Teller's nuclear work appears in textbooks even today. If history went another way, he could have been a quiet, elegant scientist, classroom names memorized, exams passed, safe, boring, even. But reality had other plans. He didn't just theorize. He built labs, created research systems, from lone scientist to architect of science. Science wasn't one person plus paper anymore. It became teams. Equipment, national resources. Teller stood right at that turning point. So what you see is a contradiction. He could write beautiful equations, and he unleashed the most violent energy on Earth. One man, connecting two worlds, quiet formulas, and deafening explosions. Without war, he might have been just a name in a book. With war, he became undefinable. Hard to call him just a scientist. More like a human measuring stick for what humanity can do. The world didn't end, and not because we were safe, because we were scared out of our minds. Cold War peak, the air? Like a taut string. U.S. On one side, USSR, on the other, birth stuck in the middle. And humans learn something strange: fear keeps peace. Counterintuitive? Totally effective? Absolutely. If you can destroy me and I can destroy you, best neither of us moves. This is nuclear deterrence. No contracts, no trust. Just you move first, we're done. Elegant? No. Absurd? Yes. Effective? Also yes. The logic has a name: mad, mutually assured destruction. Crazy, right? The name says it all. Two people, buttons in hand. Who presses? Both offline. So they don't press. The most ridiculous piece in history. Don't move, I dare not move. It held for decades. Weapons multiply. Power grows. Atomic bombs, hydrogen bombs, multi-strike systems. Every upgrade? Not for use. To scare the other side from using theirs. And behind all this, scientists, people like Edward Teller, their calculations and designs became reality. But when your work can end the world, are you still just a scientist? The story gets heavy here, because we need to ask. It's not about what he did wrong. It's about what he could do. Science has no morality. It's a knife. You can slice bread, or hurt someone. The question is who wields it. But what about the inventor? Responsibility? Some say no. I just made the tool. Some say yes. Without me, this choice doesn't exist. In Los Alamos, debates raged to conference rooms, hallways, dinner tables. Some wanted to stop. Some couldn't. The reason? Simple: if we stop, someone else won't. Responsibility blurred. Was it the scientist? The state? Humanity? No one had a clean answer. Teller chose a path forward. No looking back. No regrets. On the surface, at least, the question didn't vanish. It just changed form. Every time nuclear weapons came up, the question returned: quiet, stubborn. How far should science go? How far should humans? Once some doors open, they never shut. He won the war, lost friends. Late life stage, still on the stage. Applause tasted strange. Teller remained active, vocal, firm, nuclear advocate, defense systems. Even the Star Wars program, people reacted. He's still raising the stakes. Science world? Split. Some, realist, did the safest thing in a dangerous world. Others, reckless, pushed science too far. Step by step. The result? Teller stayed top scientist. Not popular. Conference vibes? Awkward. Some nodded. Some silent. Some avoided him. He was basically mentally blacklisted. He didn't seem to care. Or maybe he chose long ago: of fame or safety? Recognition or power? He chose power. Center, yet on the edge, needed, yet avoided. That was his later life, not failure. Not easy victory. If Einstein opened the atomic age, Teller? He kicked the door open, and behind it, he put a sun. Humanity held this power, and for the first time, faced it. The question, not can we destroy the world? But when will we decide not to?
The people who change the world usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.